This is the video for Mod 7 Lesson 3A, Segment and Angle Bisectors. So the goal of this lesson is going to be using properties of segment and angle bisectors. We're going to identify and apply properties of midpoints and segment bisectors, and then also apply and identify properties of angle bisectors. All right, so for topic 1, we're going to be looking at midpoint and segment bisectors. Midpoint, you might remember from Math 1 a bit. It says a point that divides a segment into two congruent segments is a midpoint. So basically, if you're given that a point is a midpoint, it's actually going to be cutting the segment in half. So what that means is whatever the length of AB is, if C is in the middle or the midpoint, it's like the halfway point, and these two lengths created are exactly the same. So we would say AC is equal or congruent to CB. A segment bisector is very similar. It's actually a line, a ray, or a segment that divides the segment into two congruent segments. So essentially it passes through the midpoint. So in this case we have GH, which is this line, is bisecting segment DF. So this is DF right here. So I'm going to go ahead and mark that these are the same. And so we have here that DE is congruent to EF. So these two segments are going to be the same length, and actually E would be the midpoint based on the previous definition. So the first example, we have BD bisects AC and find the value of X and BC. So if BD bisects, we got to kind of decode what that means. So BD is bisecting segment AC. So this is AC. So what that means is we have two congruent or equal segments. So we have essentially, that means that AB is equal to BC. If we want to find the value of X, I know that this expression of 6X plus 7 is equal to 9X minus 8. And then we're going to go ahead and solve for X. So if we go ahead and subtract and solve, I'm going to subtract 6X. And then just simply add and solve. And so we're going to get our value for X to be 5. So whenever we have a point that's a bisect, or something that's being bisected or midpoint, it's making two equal segments, and you're setting the values of those segments equal to solve. Now when we have X is 5, the question also asked for BC. So we're going to take this 5, substitute it in for BC. So 9 times 5 minus 8. And we're going to get our answer to be 37. So really the length of BC is 37 units. So this is a length of 37. The next definition we're going to talk about is an angle bisector. So angles and sides are different. So angles obviously are measured with degrees, like we kind of saw already. So if a line, ray, or segment divides an angle to two congruent angles, it's an angle bisector. So in this case, it says AC is bisecting this larger angle. So what that means is it's dividing the angle into two equal angles, right? So whatever the measurement of one angle is, it's the same as the measurement of the other. So if I was going to name this angle, I would name it BAC. So the measurement of BAC is going to be the same as CAD. So if this was 30 degrees, the other angle will also be 30 degrees. In the example, we're given, again, it's kind of just decoding what this is saying. So VP bisects UVT. So UVT is this angle right here. So if it's bisected, that means that angle 1 and angle 2 are the same thing. They're the same measurement. We're then told that angle 1 is 2x plus 8. Angle 2 is 4x minus 2. Sometimes it helps to label the expressions in there so you could see it a little easier. And we can see that 1 and 2 are marked the same, so their expressions have to be the same. So I'm going to go ahead and set these expressions equal. So 2x plus 8 equals 4x minus 2. And then we're going to go ahead and solve. So I might move the 2x and solve. So we get x is equal to 5. Again, that's not the final answer, though. They want to know what angle 1 is. So if I go ahead and substitute that back in for angle 1, you're going to get 18 degrees. For the last example, same thing. So they tell you QP bisects RQS. That means that these angles are exactly the same measurement. So angle 1 is 3x plus 10. Angle 2 is 9x minus 2. Since they're the same, I'm going to set them equal. And just go ahead and solve. So we end up with our answer of x is equal to 2. And the question is, what is SQR? So SQR is the entire thing. So if I substitute in 2 in here, 3 times 2 plus 10, 16. This is also 16. They're both 16. So the entire angle would be 16 plus 16, or 32. So the measure of SQR, which is the big angle, I'd have to add both the angles and I'd get 32 degrees. If you have questions, make sure you are trying the you-try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.